Professor Dr. Nicola Scafetta habe ich bereits gestern schon vorgestellt. Er hält heute seinen zweiten Vortrag. Diesen wird er zu den Auswirkungen und Risiken realistischer Projektionen der globalen Erwärmung für das 21. Jahrhundert halten. Professor Dr. Nicola Scafetta, thank you very much.
Okay. So I would like to present this recent research, impact and risk of realistic global warming projection for the 21st century, which has been actually published a couple of months ago on Geoscience Frontiers. I believe this is an important paper, and I hope that you will share my opinion, because it will address the main topic that people should be interested in. So to evaluate the realistic risk, okay, the risk associated with global warming and because this risk is what then determines everything else. So, okay, so climate alarmism, you know all these things. I am not stopping here. So there is a lot of climate alarmism around, but actually all these pictures show meteorological phenomena that have little to do with climate change. So the thing is much more complex. We have seen this picture yesterday. This is the global warming since 1850, which is about 1 degree, a little bit more than 1 degree. Okay, the issue would be whether or not this is nature or humans. Okay, and also this we have saw this yesterday. So the IPCC interpreted this warming by assuming models who are forced with a set of functions, which are this one. These are the forcing of the supposed forcing of the climate system, and it happens here that we have a solar forcing that is nearly constant. It's very, very little, and we have a volcano forcing, which are the spikes here, and then everything else is claimed by definition to be anthropogenic. And as you see there, okay, the sun is nearly negligible compared to the anthropogenic forces. So this is what their model, okay, their model of climate change. And but as we discussed yesterday, there is a problem with this theory, because in physics, theories must be confirmed by data. Okay, so we do not have just models. We need to confirm the predictions of the models with the data. And as I explained to you, the models made two main prediction. One prediction is without anthropogenic forcing, and another prediction is with all forcing, therefore with anthropogenic forcing. So to confirm the models, there is the need to confirm both predictions. And the problem is that in the case of prediction number 2, so where we have only the natural presumed forcing, we do not have the data to back up the prediction, for the simple reason that we do not have a planet B that could confirm the prediction. And therefore, the thesis that humans are responsible for 100% of the warming is actually just a hypothesis, because it is not really experimentally confirmed, because we don't have the data to demonstrate that without humans the temperature would not have changed during the last 150 years. Okay, so we have in this situation that we do not know the things. What we know for sure is that CO2 is a food plan, okay, and therefore we see everywhere in the world that the world that become greener usually, and so also in Europe a lot of green, so in China, in America, and many places in the world. So we have this, but we know that this is due to the fact that CO2 is a food plant, okay, so it is not a poison as people may believe. But now let us understand why there is the alarm. So why people are so alarmed. They are so alarmed because, as I told you before, they just believe in climate models, because the models are not validated. Okay, and these models, what do this model do what you see in the first picture there. So the models predict this warming, okay, fine. Then the models are used to predict the future warming, because that is the point, okay? So can we believe the future climate changes that the models represent? Now, the problem is that we do not know what actually happens in the future. In particular, we do not know how much CO2 we will emit in the future, because we can choose how much CO2 we can emit in the future. So people have done several scenarios, socio-economical scenarios. So we have SSP1, SSP2, SSP3, SSP5. So these are different socio-economic scenarios that corresponds to different kind of CO2 emission. And then you have different kind of output. And then what do you see? People then use this other kind of models. These are models that evaluate the risk, the hazard, environmental hazard in many fields. And what you see here is that if you cross the 2 Celsius degree, then something starts to become red, no? Like here. So red means that there is a vulnerability, the system become vulnerable. That means that we are not able to adapt enough fast to avoid the risk, and therefore we have the Paris Agreement, okay? The Paris Agreement says that we need to keep the temperature below 1.5, below 2 Celsius degree. That is the Paris Agreement, okay? And if you look at the 4 kind of scenarios that we plotted there, there is only one scenario that will guarantee that we remain below the 2 Celsius degree, and this is the green one, the SSP1. What is the SSP1? The SSP1 is the net zero emission scenario. Therefore, we need the net zero emission scenario to keep the temperature below 2 Celsius degree, which means saving the world. What is the problem? The problem is that nobody is actually doing the SSP1. We will see in 1 minute that people are doing at the most SSP2, but SSP2 is not enough to save the world, and therefore we need to do more. We need to do more. We need to do more. This is what is behind all this emphasis, okay? All these things that are happening in Europe, everywhere. We need to do more, because only the net zero emission scenario will save the world, and we are not doing that. That is the topic. But then, so Europe, of course, they would like to do the net zero scenario, okay? And the people, of course, are protesting because they realize that it's too expensive. So it is our right as a citizen of Europe to understand whether or not the net zero scenario is really necessary, okay? And to do this, we need to have this question answered. Is the alarmist narrative based on sand or rock? This is the question that every citizen in Europe should, and also in America and everywhere else in the world, must ask, okay? We want to know whether those hypotheses based on sand or rock, and therefore we need to understand better the issue. Now, there are 3 basic critical issues that we need to address. The first issue is that which shared socioeconomic pathway is realistic. Okay, so we cannot just invent what could happen in the future. We need to find out something that could be realistic, okay, so that people are willing to do, and so on. Then there is a problem with the models. There's a problem of the equilibrium climate sensitivity of the models. And then we need to ask whether or not the models, the physics of the models is reliable, because there is the possibility the models are completely wrong. Now, in this fourth picture, you see that we have different scenarios. Then we have the models, and then we have this is the equilibrium climate sensitivity of the model. You see that the warming depends on the climate sensitivity of the model. So greatest is the climate sensitivity, and greater will be the warming, and therefore the risk will depend on the climate sensitivity, will depend on the social shared socioeconomic pathway, and then will depend also on the physics implemented in the model. So we need to address these three main topics. First of all, critical issue number one: which shared socioeconomic pathway is maybe realistic one? And what we have from Nature, this is a paper on Nature, they show us that very likely the most realistic one is the SSP2, which is the one that you see here, that is this blue one. And why it is realistic? Because all countries in the world more or less are following that path, while the SSP5 or SSP3 are too strong, are not really realistic. They say clearly highly unlikely and unlikely. And the zero emission, the net zero emission by 2050 is also not realistic because people are not following it. So you see that only the P2, which is a moderate scenario, because we will continue to emit CO2. Then after 2060, there will be this little mitigation, but it will never reach net zero and so on. And so it will be very moderate, and people are doing that actually. Well, what the IPCC does in this case is very interesting, because on one side, the IPCC highlights the SSP5 scenario, which is the most alarmistic one, okay? But it is not realistic. Interestingly, the IPCC also writes here studies that consider possible future emission trends in the absence of additional climate policy are approximately in line with the SSP2. So the IPCC acknowledges that that practically the SSP2 will be the realistic one, okay? But then they show a lot of picture with the SSP5, which is not realistic, which is highly unlikely. So they are stressing the risk. They are stressing the risk. And even with the SSP5, you see there a lot of white spots, which means that for a lot of systems, there will be no big changes, okay? Only the heat waves, for example, will increase significantly, but everything else, floods and so on, hurricanes, will not really increase. So this is written in the IPCC, okay? Okay, critical issue number two: which model could be realistic? So let us discuss the climate sensitivity issue. The climate sensitivity is a big issue, because the climate sensitivity is actually given by the initial warming of CO2 plus the feedback. And the problem is that, in particular, the feedbacks are not really well known, so how the cloud system or the water vapor will respond to a forcing from CO2. And this not just me. You just take the IPCC. The IPCC show you a lot of models, and these models show a different equilibrium climate sensitivity. I remember the equilibrium climate sensitivity is the estimate of the global surface warming achieved at equilibrium after a doubling of atmospheric CO2. And therefore, you see some models show a 1.8 Celsius warming. Other models, like the Canadian one, show 5.6 Celsius warming. This is a huge uncertainty. This means that people, the same modelists, have no clue about what CO2 really does to the climate. Okay, it's not just me or some skeptic. It's the IPCC that writes these things, and therefore they know very well that people do not really have any clue of what the CO2 really does. Yes, it's a greenhouse gas. It should warm the earth, okay, the climate, but we do not know exactly how much, okay? And that is the IPCC, okay? It's not me. Things. So we need to reduce this uncertainty because we need to determine whether we need to use the low climate sensitivity models, the medium, the high sensitivity models, and so on. And what is here? There is a lot of people who are realizing that there is a hot model problem. Okay, so many models seems to be run too hot, and this is some review of what is happening. So we have that the climate models show a climate sensitivity that goes between 1.8 and 5.8 Celsius. Then we had this paper in 2020 by Sherwood, who claims that the climate sensitivity might be between 2.6, 3.9 at 66 confidence, or 2.3, 4.7 at 95% confidence. The IPCC actually accept the evaluation of Sherwood, and they use more or less those central view. Okay, but then we have a paper by Lewis. Lewis show in climate dynamics wrote a very strong critique of the Sherwood paper, and he proved somehow that that Sherwood made several errors in statistics, and the real climate sensitivity using the same data would be 1.75 to 2.7 Celsius. Then I have several works also on the similar topic that also show that the most realistic climate sensitivity should be less than 3 Celsius degree, and very likely between 1 and 2 Celsius degree. Also Spencer and Christie agree more or less with me and with Lewis, and therefore we have several papers that show that the real climate sensitivity should be low. So essentially we have this scenario, okay? So we have that the climate sensitivity in the literature, the climate sensitivity gives that panel that is the yellow panel, no? Between 0.5 and 7 essentially. The models goes between 1.8 and 6. The IPCC chooses that range. Lewis found that lower range. I too found a lower range. Spencer Christie the same. But the interesting thing here is what other people are finding. So in this paper of Rudolstadt, so we have essentially they show early in the 2010 a substantial discrepancy was noted between estimates of climate sensitivity derived from climate models and estimates based on observed warming record. Estimates based on observed warming pointed to much lower values than those derived from models. So here we see a dichotomy. Okay, on one side there are the empirical studies, and the other side we have the model study. The empirical study show the lower sensitivity compared to the models. This is one of my paper, and you see here the data from 1980 to 2022. So you see here that we have three group of models: the high sensitivity model, the medium sensitivity model, the low sensitivity model, and it's evident from just plotting the data that the high sensitivity model are too hot. The medium sensitivity model also appear too hot, and only the low sensitivity model appear to fit the data. And but here there is another problem, because in this other picture here you see the models here, and the prediction of the model warming between 1980 and 2020. Okay, and then you see the satellite measurement. The satellite measurement during the same period show less warming than the surface record, which means that if the satellite measurements are correct, all models are essentially wrong. And this was also one result that Spencer and Christie have reached. Okay, so all models, not just the low sensitivity models, but even all models. So we have this second issue. So we need to use low sensitivity models, and there is the possibility that all models are too hot. Critical issue number 3, is there further evidence that the models may be physically incorrect? So there may be warm biases, natural variability, solar things, and so on. Oh, the IPCC, let us see what the IPCC say. Okay, the IPCC showed this picture at page 443, and here they are comparing the warming observed above the tropics, in the troposphere and then stratosphere, and you see here in black we have the data, the warming produced by the data. In red, we have the warming produced by the models, and you see that there is a big difference between model and data. So practically, the IPCC is showing us that the models do not work because they are essentially failing to reproduce the warming in the entire troposphere above the tropics, where there should be a hot spot produced by the CO2, essentially, but there is nothing. So there is this issue. Let us see what is happening at the surface. So the data may be affected by urban heat island, and we can see this in many ways. So for example, if we use the satellite record and we compare them with the surface, we find out that the satellite records show less warming. But that happens in particular on the land, because on the ocean, this is on the ocean, we have that there is more or less agreement between satellite records and the data on the, but on the land there is a huge difference, and this huge difference is we found also in several other papers, also with Willie Soon, we have found with this paper with Willie Soon and so on. So practically we have that if we use only urban station, we get much less warming than using all station. And that paper that I published, actually I find out the place where very likely the urban heat island may be stronger, or bias, surface biases may be stronger. That at the red region, you see a lot of red region in specific point where there are a lot of cities. So very likely the land records is too hot because there is a lot of urban heat island that has not been filtered out efficiently, and this is a big issue, because that means that the real temperature should be lower, like the satellite are showing us. But then there are other evidence that the models may be wrong. I showed this yesterday. The IPCC again show us that the climate models that they are using do not reproduce the medieval warm period, and they do not reproduce any warm period of the past. And therefore, this is clear evidence that the models are wrong. They are missing a very important mechanism, and which do not reproduce the warm period. So it's the IPCC who is showing us this picture, not my picture, although I have published something like that. The medieval warm period, we have many evidence in Europe. It's very clear that we have evidence of a warm period and of other warm period in the past. And this we have, and we know that the sun is the only thing that could be responsible of this warm period of the past, because we found a good correlation between the solar record and the climate record. So we discussed this yesterday. So what is wrong in the model? We could have wrong solar irradiance model, but there may be also additional solar forcing not related to TSI, to total solar irradiance, and which the model don't have. Okay, so there may be many things, and I discussed this yesterday. I show you that essentially it appears that the climate models are using wrong solar forcing. They need to use a different kind of solar forcing compared to what they are using. And in addition, the climate may be sensitive to the sun in two different ways. It may be sensitive to total solar irradiance, but also to other mechanisms related to solar activity, like cosmic ray or other things that are actually modulated modulated by the magnetic field of the solar activity. And by the calculation that I proposed in this paper show that essentially up to 80% of the solar influence on the climate may not be caused solely by total solar irradiance forces, but rather by other solar climate processes like for example this magnetic. So up to 80%, maybe less, but up to 80%, which means that if the climate models are missing important mechanisms, solar related mechanisms that amplify the effect of the sun on the climate, the models are completely not physical, so they are missing huge mechanisms. And we know that from empirical study, because the models don't get at all the warm period of the past, who can only be explained by solar activity. And okay, Svesmark then Shaviv will explain you why the sun could influence the climate by directly modulating the cloud system. But so I will not focus on this now. So we have these things. We have low climate sensitivity model might be at most correct. We need to use only, we can use natural solar variability, and we can consider that there might be some contamination from urban heat. If we put together all this information, we can have 3 different kinds of prediction for the future. Consider that we need to use only the SSP2 scenario, okay? Because the other one are not realistic. So by using SSP2 scenario, we have these 3 here we have 2, then we have the third one. So we have the first case, we have only, okay, we use only the climate models that have a low climate sensitivity. In the second case, we do the hypothesis that the temperature is too hot, because and so we scale the models on the satellite records. So we need to scale down by 1/3. So the model, because the satellite records show 1/3 less of warming, and so we get that prediction for the 21st century. And you see that both in the and then okay. And then we use this model that I showed you before, that is always produced by SSP2, and then we have, but we have the cycles here. We have the cycles associated with solar activity, with the fact that the climate may be hypersensitive to solar activity, and so on. And that is the prediction of the model for the 21st century. And what you see in these 3 simulations is summarized in this picture that I think that is extremely important, because there you find the IPCC prediction according to the 4 scenario, and you see that to satisfy the 2 Celsius Paris Agreement goal, you must use the net zero emission scenario. And therefore, if we would like to save the world, we are forced to use the net zero emission scenario. However, if what I told you is correct, and I show you the evidence that what I told you could be correct, by using the SSP2, which is a moderate scenario, we get the same warming than in the first case by using SSP1. So you see, we can save the world by using the SSP2. We do not need the SSP1. So if you would like to satisfy the Paris Agreement, you do not need the SSP1, but SSP2 is fine. And SSP2 is something that everybody would like to do, because that means to be careful, to improve our technology, to optimize our technology, and so on. So, and then we will see what happens in the future. But the difference between SSP1 and the SSP2 are billion of euros. Okay, so it's not small thing. It's not small. There may be 1,000 billion of difference between SSP1 and SSP2. So this paper actually prove it. Now, some economical issue. Okay, what is happening in the world? Because now we would like to save the world, but we need to see whether everybody else agrees, okay? So here I put Italy and China, okay, because I am Italian, okay, but here I put the data from Europe. And practically, we see that Italy, like Europe, is decreasing the emission everywhere, but China is increasing the emission everywhere, okay? So that is the situation. Now, it is important here to see this number here, that is the tons of CO2 equivalent per capita, that one per capita, per year, so the emission per capita in the countries. So you see that in Italy, for example, this emission is 6.7 there, and China is 10.9. So in China, actually, they are emitting much more CO2 than in Italy per each person. So in the case of Italy, perhaps we do not need to do too much, because already we are emitting much less than China. Germany is not like that, okay? Germany is emitting, but the problem is that all Europe together represents just 6.7% of the total emission of the world. 6.7%, all the 27 countries of Europe, okay? Now, you see, this is the situation, the real situation. In all Asian countries, they are building hundreds of coal plants, okay? There are hundreds. So how can we reduce CO2 emission if they are building so many? So they don't care about all this stuff that we are doing in Europe, in America, and so on. So they really don't care. Also Japan, and South Korea. So it's not just China and India or Indonesia. They are doing hundreds of these. These are the emission, the trended CO2 concentration residue from 2015 to 2019 of CO2. You see that Europe does not really emit too much compared to China or India or even other countries. So you see that Europe is okay. It's okay. So it's not, we are not emitting. We are not really the main emitter. Europe is not. This is another important paper, but however, this is Richard Toll. Here, he is a very famous economist, and here is comparing the cost of meeting the Paris Agreement with the benefits of meeting the Paris Agreement, okay? And you see here that the cost is far higher than the benefits. So, what are we doing? So, economists know this data. The cost is much higher than the benefit. So, what is the logic? There is no logic. This is another paper by very important geologists and very famous geologists. These are the top geologists of the world who are saying that be careful that there are no minerals to do the energy transition. Okay, so however, indicate modeling of the nexus between clean energy and critical metals requires for low carbon solar and wind technologies and electric vehicles and their charges indicates that many metals, particular cobalt, nickel, ram, okay, and so on, may be severely to terminally depleted by 2060. Making further low carbon technology production impossible. So there is no material to create that technology, the green technology, okay? And these are the geologists who are saying that, okay? So that they are proving that. The electric car, okay, I don't want to spend time. That is the Italian electric car, Dora, in 1906. That was the first car to be invented, and then all these cars bankrupted when the engine motors were created because of the problem of the batteries. So the electric cars are the past, are not the future, are the past that already passed. Okay, so that is the situation. But the Italian cars was very pretty, no? Okay. Okay. So let us do some calculation because we need to do calculation. Okay, will Europe be able to save the world? Okay, let us do this exercise. Since 1900, the temperature has increased by about 1.1 Celsius, and since 1900, the CO2 has increased by about 110 parts per million. So we have about 1 part per million of CO2, which is equal to 0.01 Celsius. Okay, so that is it. CO2 is now increasing at a rate of 2.5 parts per million per year in Europe, contributes 6.7% of all global emission, and therefore could at most be responsible of 2.5 times 0.067 equal 0.0017 Celsius per warming per year. If we reduce emission by 40%, which is more or less the net zero, no? Decided by Europe to reach net zero 2050, the climate gain will be 0.017 times 0.4 equal 0.0007 Celsius per year. Okay, that was the gain. This means that it takes 15 years of our economical starvation to save just 0.01 Celsius of warming, but only if China, India, etc. will permit it and will not take advantage of the fact that we are closing our factories and they will build them for substituting them. Okay, so that means that, in my opinion, there is no reason to continue these things, and I think that I have demonstrated here very clearly that net zero policies are not valid. You may perhaps just use this paper, just published 2 months ago, okay? That's it.